Hi guys, and welcome to another Devcast. It's the second one this weekend. So today we are going to talk about Unity and Houdini and how to basically take any prefab, any geo from Unity and destroy it in Houdini and then bring it back to Unity again. Let me tell you, I really love Houdini. I use it a lot for my personal projects. I use it a lot for experimentation. I use it a lot for some effects as a guy that comes from the demo scene uh, days. I always experiment with various simulations, party flag effects, geometry effects, and so on. And Houdini is a great tool for that. But I also think it's a great tool for asset development, especially for game industry. And I really like that a lot of game companies are using Houdini now for procedural generation, for asset modification, and so on. But let me tell you, we still don't use Houdini inside our company, and I think that it's a shame, but we'll see what we can do about it. Because, for example, this is a great example from our games where we need a new building and a broken down building and have these both these assets, and I think Houdini is a great tool to achieve this. So we'll see in the future. At the moment, it's just my favorite toy. Another thing is, and I want to mention, this is a really simple tutorial how to break the asset. So there are things that you can probably see right away that there is no inside geometry, for example, for the building. So it looks like a rock inside, and that's because the geo wasn't prepared for breaking. So that there was no inside geometry generated. You can either use your own geo with some kind of inside geometry. You can also use Houdini for to procedurally generate the inside geometry. It would be easy because it's easy in Houdini to generate some kind of walls inside and boolean out the inside and so on. But it will be not part of this tutorial. So if you are interested in that, just write to me and I may do a second part with this distraction, which will have an inside interior geometry. So let's start. I have a very simple scene inside Unity. I have a Houdini engine installed. I already connected it. If you are using it for the first time, you just run it. You have this editor window, and then you can either start or connect to Houdini. It will start Houdini, and it will create this empty project with a global node subnetwork that we are not going to talk about because it's not relevant for us. And it's connected. It's working. Another thing I want to mention is that I bought an asset from Cindy Studios. I have a lot of their assets. This is great asset for buildings. It's called Polygon City, and I think it's currently in sale, Black Friday, you know. So go grab it. So we have all these buildings here. I'm using Universal Render Pipeline, that's why this is pink, even though I already converted the materials to the Universal Render Pipeline. The Unity doesn't recache the previews for the prefabs, but as you can see they are working. So let's take this geo, put it here. Okay, center it. My camera is orthographic, as you see, because I like to work with orthographic camera. I just like that. I'm an old school guy, so but that does not really matter. So now we have this building geo. So let's start with the Houdini magic. Go back to the Houdini engine session, and what first we want to create a node called import, and it will be an input node because we want to take an input the geometry and get it into inside Houdini. So let's create it, and it's created. Let's check the Houdini and the geometry input is created as well. But what we need to do, as you can see, there is no geo at the moment, is go to this game object we just created. There is this Houdini engine component, and we want to add a slot. It will be a Unity mesh. So, and let's drag the geometry data there. It will duplicate the data, so we can just basically turn this off. And we have this geo. What it did in Houdini is it created another two geometry nodes. It created a geometry node for the input for the first slot we just created, and then it created a merge node because if you have a multiple inputs, it needs to merge together. So that's why it created the merge node. Let's forget about Unity for a while, and let's work on this nice geo we just got inside Houdini. So we want to break it up. So let's create a new geometry network. I always create a new network. I don't work. You can work on this merge or any of the networks, but it's always create a separate network to just decouple it, like in programming this direction. And let's jump right in. We want to merge, object merge, and we want to get the geo inside. We will take the merge node, so it's now inside our distraction merge, and I will just turn off all these so we only see the one we are working with. And let's pause for a bit here. I want to talk about this geometry. Uh, Many times when you get the geometry from asset store or somewhere else, it may not, and it probably isn't optimized for such stuff like breaking it out, or because let's look at this geo. The topology is like it's questionable, but it's okay for what it was designed. It's not okay for breaking, for distraction. For example, it's open. So if you really want to do distraction, you should have a closed geometry. And also, if I just take this, it's not a single object. I can explode it. So it's multiple pieces, and you will see it's all these pieces. So if I just put this into simulation, all this stuff will just fall off because it's a separate piece from the beginning without even doing any distraction on it. So just take this into mind. You can fix all that using fuse and stuff like that in Houdini. I'm not going to do that because it would prolong the tutorial. But you can do that. But you can also, like, when you know that you are going to destroy this building, you can keep that in mind, and once once you bring it into Houdini, it will be already prepared for all this distraction madness we are going to do. So there are many ways how to destroy an object in Houdini. I'm going to use the standard, the simple one, using a fracture, a Voronoi fracture. It has two inputs. First is geometry, so let's plug it right there. A second one is the Voronoi cells, so the points for Voronoi cells. So it's basically the points where the cells will be generated. So we need to get some points. We are going to get a scatter node and scatter some points inside the geometry. You can see them. Let's not use total count. Let's use the density and some small number, even smaller, just to break it up a bit into bigger parts. And now put it into the fracture. It's calculated the fracture. As I said, there are already some artifacts that's due to the geometry, but it doesn't matter. It will look good for what we want to, and we can preview the fracture geometry by exploding it. And that's pretty much for this network. So let's create a null node to export this geo. Let's call it destruction out. I always create this. It's a standard workflow, so you know which is an output node. And I can just plug it here. Don't do the null, the out after the exploded view, because you don't really want to simulate the exploded view. That's just for debugging. Okay, that's all for now, and we want to create a simulation. So let's create a DOP network where we'll do the simulation. First, we need to get our object into the simulation. So it's a fractured object, so we are going to use the RBD fractured object and get the null out. That's why I do it. So it's readable. You get the distraction out. If you saw any Houdini tutorial on internet, they probably do it as well. So it's as I said, it's standard. So we have it here. And again, disable this one, so we only see the simulation. And let's jump right in. We need a solver for the rigid bodies, and we need the gravity, obviously, and We also need, because at the moment it would just fall through, there is no plane. As I said, we do have plane here, but I didn't import it. You can import it. For example, if you had a terrain, you can set that as a slot to import it inside that and use that as a static rigid object to just basically collide with this distraction. But at the moment it's just for the simplicity, we just want the plane and we don't really need to import the plane because Houdini has the ground plane. And we need to bring it back to the simulation. So let's merge these two. Always merge the ground plane first. And okay, that's pretty much our simulation. Let's try it out. There is, oh, we didn't switch the output. Now you can see it's collapsing. Okay, we still have like too many pieces. Some of them are the default pieces, as I said. First, I will turn off this geo of the plane because it would get imported into Unity as well. We don't really want that. And then go to the distraction, and let's bring this even lower and go back to the simulation. So it just destroys itself. Okay, let's go with this. And now we want to see it in Unity. So we need to create once again. I will move this. We want to create some kind of export node. So let's go to the Houdini engine session, and what we want to create is an experimental SOP subnet. Let's create it. Or I don't really want that import. I want the export. Now I need to export. So we have this export, and as you can see, it has no children and it has a different component. We just we use it for the syncing with the Houdini. Let's check Houdini what it did. So it created this export geo for us, where there is a subnetwork for exporting some inputs and stuff like that. So if we bring our geometry here, we can bring it to Unity. So let's go again, object merge, and we want our geometry from the simulation. And we have this simulation, and we don't see the output. Why? Because it's not the geometry. So let me do a few things. First, I'm going to rename this to simulation so it's more readable. I should have done that at the start. And secondly, we don't see this node because it's not a geometry, so we then need a sub geo node. So this will be converted back to geometry. So let's go to the export, and now we will see inside our simulation sub geo. And now if I go to Unity, it's already synced, and we see the geo. If I go a few frames back, you'll see how it's breaking out. So let's simulate it a bit further. Show you a few things. Okay, that should be okay. Now we see that actually this geo, if I just check it because it created the geo, has only one material, which is the material we are using on this building, but it's the outside material. We don't really see the inside because the inside, as you can see it, here are some artifacts, and here uh, keeps using this material, and that's not really what we want to. We want to specify another material for the inside geometry. But actually, it's quite easy. But it's different how if you worked with Houdini. Let's go to the distraction, and we want to, before we put it out, we want to create a material. You are not going to use the material. If you wanted to assign a material to some geo in Houdini, you would use material. To get it inside Unity, it needs to be an attribute, obviously, because it basically looks over the attributes. and that's how it knows that there is a different material on this attribute. So let's create attribute for this. It's going to be called a special name. It's Unity material. You can look at this and in the documentation. There are a bunch of other preserved words how to export stuff to Unity. It's called to be a Unity material. It's also going to be string, and it needs to be on a primitive because we are going to assign the material on the pieces on the primitives. And the value of it needs to be basically path inside the asset folder for Unity. I also already created a material called inside mat, and this is the value that needs to be specified. So let's do it. It's assets. It's my funny folder structure. Don't really take into account because I always use these folder structure that like, okay, this is all the external stuff from asset store, from plugins, and this is just the project stuff. That's why I have the assets, materials, inside material, mat. Okay, so and this will bring the material to the object. But if I go now back, we will see that it just changed the material of the whole object. Why? Because we didn't specify a subgroup that should use this material. We already have this information because the Voronoi fracture has this when it by default exports these groups, which is the inside group and outside group. Inside group is the group for the polygons generated inside the destruction. So we just want to specify that this material should be used for the inside group. If I go back, I already see that uh, there is this material used, and I'll check it. There is this default material we imported geometry with, and now the inside material. So let's just go and simulate a few steps. Just so we see it. Okay, it's collapsing. We see two geometries because we are working with the object. I just switch here. Okay, let me pause. And let's go back to Unity, and now you see that the inside material is a different, so we can work with that. Another thing is that it just collapses as a whole. From the screenshot, from the introduction screenshot you saw, I just collapsed the half of the building. So let me do a quick show you quickly how I did that. It's pretty simple. So I will add it inside this tutorial as well. The thing is to work with the constraints, because once you do Voronoi fracture in Houdini, you can get the constraints out of that as well. And we need to just take these constraints, specify a glue attribute that we will use for the simulation. So let's specify that these should be glued together and should not move basically. So what I need is attribute create for the fracture. Let me show you the constraints as well. Just click this. I just want to see this is the constraints for the Voronoi cells basically. So if we take them, specify and as a constraint name, and it needs to be a few things. It needs to be a primitive, it needs to be a string, and it needs to be a glue. Okay, so now we can bring this, and let's, as I said, I want to export it inside the simulation. So let's do it like this, and we need to bring it into the simulation. To bring that, what we need is a constraints network. constraint network, and specify the constraints. As it said, you need to have a source with the constraints. So to have a glue constraint relationship, there are many relationships. But we are going to use, as I said, we want the glue for us to specify the glue between the objects. So let's plug it in. We don't see anything. Let me switch this to wireframe. So we will see them. What we need to specify here is we need the path for the constraints, and we need the attribute for that. Okay, so I will just okay, let's work. We don't have that. Constraint name. We probably didn't name it correctly. So let's check it out. Constraint name. Okay, probably a typo on my part. Yeah. Okay. So let's simulate. Constraint name. It's not missing. So okay, still typo. I didn't sleep for for many hours today, so that's probably the issue. Now you see it. So now we see the constraints, the glue between the pieces. So if I just ramp this up, you will see that basically only the geometry that was piece before we did the distraction is falling off. All this stuff that I showed you at the beginning. All the others are not falling off because they are glued together really strongly. We can do various things to modify these strengths, but the most simplest way just to collapse half of the building is go here and basically delete half of the constraints. So what we are going to do is just enable bounding box. Okay, that's it. Let's go like 30, 30, 30. And you can see it uh, just deleted some of them. So let's go this way, and just we want only the half of the building to be glued together. So now we go at the beginning, and we want to see the simulation. You see that the glue, there is only half of the building is now glued together. And if we run it, the right part of the building starts to fall off. So let me switch this to smooth shaded and just sync it back. You see, okay, let's just run it further. We probably deleted too many of them. It's but it's funny simulation where you see that this one is falling off because too many of these fall off. Pressing the output. So what we can do is obviously modify the bounding box for the we delete it. Firstly, we don't really want to delete the ones that are at the bottom, so it just gets kept together. Yeah, okay, let's wait. Doesn't really want to fall off, but it will. It will. There is no glue. It just takes time. Just keeps collapsing. Nice. Okay, let's speed it up. So let's bring this even further inside the building, because we don't really want these parts to hold to these parts. So now it should collapse further. Once nothing is holding it. Still doesn't want to collapse, yeah. Okay, so what we can do is bring this number a bit higher so there are more pieces. So it's more, the probability for them to collapse is bigger. As you can see, now it's getting cracked and now it's collapsing. Once this falls, most of them will fall. So let's wait a little. Come on, I only have 240 frames. No, 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 no. It's kept collapsing on the other side as well. So let's go back. We deleted too many. Modify it. I run the simulation again. The left side seems more stable. So let's see what the right side will do. This is always always funny to work with rigid bodies. It's a toy. Okay, so let's stop the simulation, go back, synchronize it, and as you can see now you have a partially destroyed building. I can go over this simulation and modify it to the state that it was for the screenshot I created, but you get the point. It's up to you to modify the simulation and the glue for your liking. So, and that's all basically for today's tutorial. And if you are interested in any of the stuff that I just did, and you need more information, just write into the comments, And as I said, if you want to see some, for example, like the interior generation for the building and stuff like that, it's doable. I can do it. So if there is enough feedback, uh, I will I will give it a try. So that's all for now, and thanks for watching.